is going to be data modeling with PowerPivot. This is me. That's me standing in Italy in front of the Ponte Vecchio Bridge, which is one of my favorite shots. My email address is kvic@pragmaticworks.com. I am a senior consultant with PragmaticWorks. I've been with PragmaticWorks about 2 years. Prior to that, I had 12 years with Microsoft supporting SQL Server. So I've been around the SQL Server environment. Actually, I've been supporting it since 1994 when it first came to Microsoft. Prior to that, I was doing Sybase, which, if you know the history of SQL Server, is the birthplace of Sybase, was where SQL Server came from. So since that was a perfect poll that we just did that talked about who this webinar, what you guys' experience is with PowerPivot, because I really want to focus on who I designed this webinar for. I have taught the PowerPivot class now at different companies as well as the public class probably 12 times in the last year. And one of the things that I notice when I teach the class is that people pick up the technology part of it pretty quick, but they really struggle with the data modeling aspect of it. So I decided I wanted to do a webinar that really focused on people who use PowerPivot, people who are pivot table builders, who have taken the class and still struggle with how to build that data model that is the basis for what we do in PowerPivot. This really is not aimed at that 2% of you who said you were experts, but I'm happy you're here, and you can feel free to question me as we go, and I'll try to take questions at the end. But that's really not who the webinar is aimed at. It's not aimed at IT people, unless maybe you're that developer who doesn't know how to data model. Then yes, this is aimed at you. The one thing I want to make clear is this is not a class on dimensional modeling. I actually do data modeling, and I've done it for a long time. Excuse me. But I'm not intending for this to be a formal class. Some of the things I will go through in this class are related to dimensional modeling, and that's where the basis of all this comes from. But I'm not going to be as technically strict as I would be in a dimensional modeling class. It's also not a PowerPivot class. I am making an assumption that you're a little bit familiar with PowerPivot. I'm not going to assume that you're an expert. My goal is to just help you better understand all of this terminology that we use so that you'll have more success with PowerPivot. I have sort of a secondary goal, and that's that those of you who are building PowerPivot models are probably working with your IT department in order to get your data. And I want you to have a better time talking with them, and I think your PowerPivot models will be a lot better if you have an opportunity to speak the same language that they're speaking. So let's talk about what's important about the data model in PowerPivot. If you've used PowerPivot, if you haven't used PowerPivot, PowerPivot is a tool that we use from Excel in order to build some user-level data structures. And the model is the blueprint of that data that we have to use. So building our data model in PowerPivot, what makes it so important is it really is the key to success in using PowerPivot successfully. It has a huge impact on performance. If you build your data model incorrect, your performance is going to be terrible. If you pick, for example, a single table and load all of your fields in a single table, the performance isn't going to be as good as if you load it in the correct format with multiple tables. One of the things I'll say about that I've learned is that teaching the data modeling section of PowerPivot is one of the least technical aspects. Once you're inside the tool, when we talk about modeling, it's not a huge technical challenge, but it is very business specific. It's probably the most difficult thing for a non-IT person to understand because it's mostly theory. A lot of this is theory. How we design these things, this is all stuff that we learn in data modeling theory. It's very hard for me to teach the modeling piece because it's a lot of theory and it's so specific to every business. Every company's data model is going to be different. And unless you happen to sell bicycles, which is what AdventureWorks is, the sample database for Microsoft, then when I teach the class and I use AdventureWorks, it's hard a lot of times for people to relate that to the business that they're in. So let's go through some terminology. That's the first place I want to start in this, is with terminology. I just want to talk about what everything means, because I will use these terms and I want to make sure everybody understands exactly what I'm talking about. The first term, of course, is PowerPivot. I almost didn't include this slide, but I just want to level set, make sure we all know what we're talking about. PowerPivot is the tool from Microsoft that's based in Excel that allows us to store a lot of data. It breaks the million-row limitation that Excel has. What it's really doing in the background, and this is the key to understanding PowerPivot, what it's really doing in the background is creating a structure that we call a cube that lets Excel automatically connect to that cube, and you build pivot tables off of that cube. So PowerPivot is really, you can think of it as an end-user cube that we build in order to build pivot tables. Many of you who have used Excel in the past have connected to larger cubes, multidimensional cubes that come from Microsoft Analysis Services or SSAS or some other technology. So you're familiar with connecting to them. What PowerPivot does is lets you build your own cube and then connect to it with your pivot tables. So what the heck is a cube? I just used terms and I want to make sure I define them. A cube is, if you've never heard this term before, it's basically a structure that came out of the three-dimensional modeling world. This is a term that's become kind of generic for data analysis structures. So in data, we talk about databases, and that's our generic term for how we store data that goes behind applications. A cube is kind of our generic term for how we store data for analysis. So I put a little picture on this slide of a cube, and just so that you kind of get an idea where the term came from. The term came from this idea, if you look on it, when we measure 3 points in space and we have 3 axes, then an X, Y, and a Z axis, what we end up with is a shape that kind of looks like a cube. I almost put a Rubik's Cube in here to demonstrate cube, but that was too obvious. I like this one because it sort of shows you we have 3 axes that we're measuring and we pick a point out on those 3 axes. Each one of those axes is a dimension that we measure things by, the X dimension, the Y dimension, and the Z dimension. Now, in the real world, what you and I look at can only have 3 dimensions. We can map an X, a Y, and a Z dimension. But in math and in theoretical modeling, what we're doing here, we can have way more than 3. If you think of each of those axes as something that we measure by, we can actually measure by a lot more than 3 things. I just don't know how to draw it. So the representation that I'm showing you on the screen, which is where the terminology came from, that's where we get the term cube. Measuring 3 points in space gives us a 3-dimensional model of something. And you'll notice that while some TV shows claim to be 4D, the reality is we only think in these 3 dimensions, X, Y, and Z planes. So think of that when I say the word cube, but understand that what we're doing with our cubes is we're going to allow you to measure on more than just three dimensions. We can measure on 5 or 8 dimensions. All right, the other term that I use that I want to make sure and understand is, what is a data model? One of the things that struck me when I very first started teaching PowerPivot is that I had been doing data modeling for a long time, and when I was teaching the class, I realized that the way that they're using the word data model was slightly different than what I was used to thinking, and I had to kind of adjust my thinking. So let's talk about what a data model is generically, and then we'll talk about what it is in PowerPivot. A data model, when you hear that term, is basically a blueprint for data organization. So I build data models and have been building models for 20 years. When I build a data model, it's kind of like when an architect builds a blueprint for your house. I can have different types of models that focus on different areas that I need to look at. But basically, it's a large blueprint that tells me how my data is organized, how it's structured, what the business rules are. It might describe information about the attributes. A really well-defined data model tells a data developer everything they need to know in order to go out and build a database to support that model. So really what it is doing is it's describing the relationship between tables. It describes tables and relationships. So what we see on a data model are these boxes that represent tables, and we see lines that describe the relationship between the tables. You're also going to hear, especially when you talk to your IT department, that there are two different kinds of models, data models that we look at, logical models and physical models. A logical model is a model that we draw that explains the rules of the data in the business. So a physical model, I'll go back to logical in a minute, a physical model is how data is actually stored in a database. So I can actually have two models, one that describes how the data is stored and a different one that tells me what the business rules are. And I'm not going to go into detail because, again, this is not a modeling class. I just want you to be familiar with the terms. If someone asks you about a logical model versus a physical model, you want to think, okay, the logical model is telling me about the data, but it isn't necessarily how the data is stored. A physical model is the actual model of the database. Where you guys are going to hear these terms is that PowerPivot, the data model inside of PowerPivot, is actually a logical model. It is not how PowerPivot stores the data. When you go talk to your DBA to get access to your data warehouse, they're most likely going to show you a physical model. They're going to show you what the tables are, what the columns are, and that's physically how the data is stored. So just be aware of that terminology when you're talking to people. Understand that PowerPivot, the logical model that we're building in PowerPivot, means that the data behind that model is not stored the way we're going to look at the model. Whereas when you go to talk to IT, you're most likely going to get physical models from them when you go to look at your data warehouse databases. All right, so I used some more terminology. Let's keep defining some terminology. What's a table? So you heard me say that a data model represents tables and relationships. So what's a table? In database terms, a table is a collection of fields, and we would call them attributes, and rows, we would call them tuples, that make up some sort of logical connection of information. I put an example of a table on the screen. This table has 3 rows in it. It also has 3 attributes. The 4th attribute, the column that says row, is actually just the number of each row in the table. So my row number 1 is Bob McBob, and he's 42. That has 4 fields, 1 key field, and 3 attributes. The key field is the value that I can use to find just that row. It's what makes that row unique. How do I tell one row from another row? That's normally, in most cases, you're going to find that that's a computer-generated number that makes it unique. And one of the reasons we do that in the data world is because sometimes it's kind of hard to determine what makes a row unique. And sometimes, think about this, think about Bob McBob. If Bob McBob has 5 kids named Bob, which actually George Foreman does, if you know who George Foreman is, he has 5 sons named George Foreman. How do we tell each of them apart? The only way to tell them apart is to look at a lot of different attributes, and that combination of attributes is what makes him unique. So George Foreman's number 1 son has a different birthday, so that his name plus his birth date is what makes him unique in a computer. What we do is we say, wow, if it takes 2 or 3 or 4 fields to make it unique, we're going to give a number to that row, and that will make that row unique when we're working with the data. So when you are talking to your DBAs and you're talking to them about tables and keys, you want to understand that there are most likely 2 sets of things in that row that make it unique. One of them is this idea called a surrogate key, which is a machine-generated number that we assign to that row that says, okay, now I know what your ID is. There's almost always what we call a business key, which is the logical collection of attributes that really, from a business perspective, makes that row unique. So if we think of George Foreman and his 5 sons named George, it's probably their name and their birth date and maybe their social security number that we use to uniquely identify them. That combination of fields is what we would call a business key. You're going to need to know that when you talk to your DBAs and when you're looking at your data, because as you start connecting the data together in your PowerPivot model, it's the keys that allow you to connect data together. And whether it's a surrogate key or a business key has a huge impact on how you match your data up in your PowerPivot model. And we'll talk about that in a little bit. The important thing I want you to remember from this slide is that keys can have one field or multiple fields, but PowerPivot only allows you to use a single field to define a key. So if you were working with your DBA and your DBA gives you a table that looks like my table, the key that's in the column row that gives me a record number is the key I'm going to want to use when I'm in PowerPivot. If I happen to be matching that data up against something else that doesn't have the same key, then I need the guy's name in order to make him unique, or I need some combination of fields. And we'll talk about what we have to do in PowerPivot a little later. So I used another term. I used a term called relationship. So let's talk about what relationship means. A relationship is how we connect data between tables. It defines, this was a very hard term for me to define without using the word relationship. As I started to write the definition, I said, it defines the relationship, and I went, you can't do that. So I had to think about what does it actually mean. What it really does is it represents the way the rows in one table are connected to the rows in another table. So as an example, the little model that I have on the screen shows me that an airline is related to the online on-time performance records through the airline key. And what that tells me is if I'm looking at airline performance records and I want the name of the airline that goes with my on-time performance record, I can use that airline key in on-time performance to connect to the key that's in the airline table in order to get that airline name. So we use relationships to understand how to connect data from one table to another table. When you talk to your DBAs and when you're discussing data relationships with data modelers and people who know data, and when you work in PowerPivot, you're going to hear three terms. You're going to hear one-to-one, one-to-many, and many-to-many. In the modeling that we do, those are the primary types of relationships that we use. And if you hear somebody in a geeky world, in the techie world, say cardinality, that's what we're talking about. Cardinality means a little more than that, but if you hear that phrase, you want to think, oh, okay, they're talking about the relationships between tables. In PowerPivot, we really focus on that one-to-one relationship. And it can be a one-to-many relationship works in PowerPivot. The one I want you to remember is that a many-to-many does not. So I'll give you some examples. In this model we're looking at, there's a relationship between an airline and online performance records. And it's every airline can have many online performance records, but each on-time performance record has one and only one airline associated with it. So when I say those words out loud, I realize that the one-to-one relationship is from the on-time performance to the airline. The one-to-many relationship is from airline to online performance. Now in a PowerPivot model, when you look at the model, you should be able to spot right off the bat what the one-to-one relationships are because the arrow points right at them. If you look at those lines that are drawn in this model, I can tell you that every online performance has one and only one airport, it has one and only one date, it has one and only one flight distance group. It's really easy to read the PowerPivot model because the arrow points right at those one-to-one relationships. For those of you who have used PowerPivot, where this is absolutely key is when we go to get data. So as I said, if we're going to build a pivot table and we want to use the airline's name, we want to be able to make sure and aggregate the records that belong to that airline. We have to know for each one of those on-time performance records, which airline record does it match up to? That's what we're going to be talking about when we talk about relationships. we're saying how do we connect our data together. In PowerPivot, the most important thing is to understand the one-to-one. You always want to draw from one to one, and so you want to be able to say these sentences out loud. My table A has how many of table B? And when you do that, you'll be able to figure out the one-to-one and the one-to-many. I said PowerPivot does not support a many-to-many. Let's think about the relationship between airlines and airports. An airline flies to multiple airports, and an airport supports multiple airlines. That makes the relationship between those two tables a many-to-many relationship. And it's one that if I were trying to do any kind of calculation in PowerPivot and I only had those two tables, I wouldn't be able to draw a relationship between those tables because it's a many-to-many relationship. What I have to do is have some other third table that says, oh, this airline flies to this airport. Then I have a one-to-one relationship between that table, which is that's our on-time performance table. I have a one-to-one relationship between on-time performance in airline and on-time performance in airport. So what you guys that are using PowerPivot, what you want to focus on is you're looking for one-to-one relationships. When you look at the PowerPivot model, the arrows point to the one. And that's something you're going to be focused on when you actually build your model. So think of that when we talk about relationships in PowerPivot. That's what you want to remember. Oh, it's how I connect the tables together. And what you're looking for are the keys that you can use so that one record in this table goes to exactly one record in the other table. I taught a class a couple weeks ago, and I think somehow I didn't make that point very clear because people were connecting tables, but they were connecting on columns that were not keys, and then they couldn't understand why their numbers didn't match up. They happened to both be numeric fields, but they were fields that were not related to one another. And so when PowerPivot tried to connect the records together, it connected them to the wrong records. The other piece of commonly used terminology that I want to just mention are these two terms, normalized and denormalized. You're going to hear me use these terms all the time. I try not to, but they always spill out. And I want to make sure that you understand what they mean because they're going to have a big impact on how you design your PowerPivot model. When I talk about data being normalized, I had to actually look up a definition that didn't use the word normalized. And I found one in Wikipedia that said, it's the process of organizing the fields and the tables in a relational database to minimize redundancy. What that means is, think about your human resources system. And in my HR system, I have a table that has all of my employees in it. In that table, I also have who their manager is. If I have that manager's name put in the record with the employee, so I have an employee name and a manager's name, and that manager changes their name for whatever reason, now I have to go out and update that manager's name in both the manager's table and the employee's record. So in the manager's record and in the employee record, I have to change it in two places. And I really have to change it in a lot more than two because I have to change it for every employee that works for that manager. What we try to do in the database world is reduce the number of places that we keep data in a transaction type system, in a system that stores, that people update data. So in my HR system, I really only want to store their name once, and then I want to use the key and put the key in the other record. So instead of having the manager's name in the employee's record, I'm probably going to put that ID field that we talked about in the employee's record and say that this is the manager ID. And if I need the manager's name, I can use the ID, go to that other record, get the name, and put it with my employee information when I build the report. That process of reducing the redundancy of data is called normalization. And we do this is a key feature in every data entry system that you're going to see. Most of your data entry systems will all try to store their data in a normalized fashion without that redundancy. Reporting systems actually try to do the opposite. Reporting systems actually like to have that data in multiple places. And they do that because if the data is in multiple places, you have to join those tables together. You have to merge them together somehow when you retrieve all that data for the report. And that can be an expensive operation. So for data entry, it's the right organization, but for reporting, it is not. And so in reporting, we actually will build data structures that do the opposite. We call it denormalizing. So that's where we're merging columns and data all together in one place to increase data redundancy, but reduce the number of joins. And the reason this works in a reporting system and not in a transaction system is that in a reporting system, we manage that redundancy, not by people having to go out and do updates, but by the computer building those records. So the denormalization is managed in an automated process, not by people having to go out and update all that data in multiple places. So for your transaction systems, when you go to your HR system, when you go to your SAP system, or your Dynamics, or whatever your accounting system is, most likely the data is going to be very normalized. When you go to your reporting data warehouse or your data marts, the data is likely to be denormalized. So don't be afraid of those terms when you hear them. That's really what it means. The data is only stored once, or the data can be stored several times. All right, that's kind of the background terminology. I want to keep going on this and take it a little farther and talk about the types of models that we build so that you can understand what type of model you're going to be building in PowerPivot and how it has an impact. I said just a minute ago that we have this concept of transaction systems versus reporting systems. You're going to hear the terms OLTP, online transaction processing, and you're also going to hear the term OLAP, online analytical processing. Those are the two primary structures for data that us in the data world use when we build applications. If we're building an application for data entry, we're going to be building an OLTP, and it's going to have what we call an entity relationship diagram, an ER diagram. These type of models are characterized by lots of tables and lots of joins. So as an example, I pulled this model off of the internet. I just grabbed a random data model off of the internet. This is a model that shows a customer who can have up to 10 phone numbers and one address. In a real world, they maybe could have more than one address, but in this model, they can only have one. If I wanted to pull a report of all of my customers' address, I would have to actually join to that phone number table, go over to the phone number table up to 10 times, and I'd have to go to the address table and join all that data together in order to produce a report about my customer. In a data entry system, that's exactly what we want. We want the address only stored one time for each row. We want the phone number stored individually. That's a great model for a data entry system. This could be the source of your data, and I want you to be aware you may have to pull from a relational model that supports an OLTP system. I hope you don't, but you should understand what you're seeing as you start to pull the data. If you see a model that has lots and lots and lots of tables, this is not a rule, by the way, this is just a guideline, it probably is the model for a relational system, and it's going to be a little harder for you to work with because of the number of joins. In PowerPivot, we want to keep the data simple, so I would want to join, for example, if I was building a customer table in PowerPivot, I would want to get my phone numbers and addresses into that table so that I have all the data about my customer, assuming I want to actually analyze by that. So it makes it a little bit less efficient to have to go get that data because we have to do all these joins and put all the data together. The other type of model that you're going to see when you deal with your IT department is the idea of this online analytical processing, or a reporting model, a data warehouse model. Normally we call these star schemas because if you squint, it kind of looks a little bit like a star. People can actually draw a star on it. This looks more like a star than that other model that I did. So you're going to hear the term star schema, and it's probably going to refer to your reporting data warehouse, your operational data warehouse, your data mart, a lot of terms that will go with it, but hopefully they'll have star schemas. You may also see inside of your star schema that they actually name their tables fact and dimension. and I'll talk about what those are in just a second. The keys to this OLAP model, to a star schema model, it is very denormalized. So I told you a minute ago about what that means. That means in my customer dimension, I don't have three tables, a customer, a phone number, and an address table. I've merged them all together into a single table that I'm calling my customer list. That's what we mean by highly denormalized. It's okay to have the data out there in more than one place. Think of your employee table. If employee was one of my tables in my model, I would pull the manager's name down rather than their ID so that I don't have to do the join to get that data. Because these have fewer tables, there's also going to be fewer joins. This is the type of model you should be striving to build in PowerPivot. And this is what we're going to walk through. How do I build one of these models when my data looks like something else? So pay attention to this star schema. We're going to use it a lot in PowerPivot. Your goal should always be to build a star schema because it's the model that works the best with PowerPivot. Now, there's a couple other modeling terms that you're going to hear. I don't want to focus on this, but I want you to just kind of look at it. The snowflake schema is probably the most common, and in fact, if you've ever taken a PowerPivot class from Pragmatic Works, we demo the snowflake schema a lot because we show you how to use some functions that help you deal with this kind of data structure. In this data structure, we have what looks like our star schema, and in fact, if you look at this part of the model that I'm trying to draw a circle around, that's really what a star schema is. But you'll notice we've got these other things hanging off of it. These are cases, the best example is in AdventureWorks, where we would have a product table as our dimension, but then the product table, because we're pulling from a relational model, it has a product subcategory and a product category table that are related to it. They have relationships between them. And we demo in the class how to use the related function in PowerPivot to go get the data from these other two tables and pull them back into our star schema so that we actually end up not needing these tables, and we end up with what looks more like a star schema than a snowflake schema. Potentially you can also hear the term constellation. It's not as popular, but I at least want to point it out. And that's when we have more than one fact table. So if you think about how what the word means, we have lots of stars in the sky, and those stars are all kind of connected. You can connect them through the different dimensions is how we do it here. But basically, if we have lots of facts in our model, then we would call that a constellation schema. The key to making that work, by the way, if you find yourself in that scenario where you have to have multiple fact tables, the key to making that work for you in PowerPivot is that your dimensions need to be shared across those. So if I have a product dimension and I have internet sales and I have reseller sales, I want to make sure that my products for reseller sales use the same dimension as products for internet sales. If I do that, then I can use one product dimension connected to both of the facts, and I can pull measures from both facts into my pivot table, and they'll work with the same dimension. What you want to be careful of is if you have a product dimension for internet sales that's different than the product dimension for reseller sales. Then I would have a reseller products and a reseller and internet products dimensions. We'll talk about that in a little bit too. All right. So let's go a little deeper into the star schema. I just said there are two types of models that we deal with. There's the star schema and there's the relational model. I said PowerPivot wants to use a star schema, so let's talk a little bit more about what those terms are that I used when I talk about a star schema. In the star schema, we have dimensions and facts. That's what I mentioned. It's a fact table in the center surrounded by dimensions. Let's talk what each of those things mean. Dimensions are labels, they're text. I think of them as the nouns in this process. So there's person, place, or thing that my business cares about. It's stuff that we analyze the business by. If you ever hear someone say, I want to see sales by product, product is the dimension. That's one of my big tips when I listen to customers. The minute they say the word buy, Just about everything they say after is talking about a dimension. Most dimensions are labels. So they're text values that we put on things that we add up numbers and sort numbers and slice numbers by. Now, a dimension can have a number in it, but normally that number represents a label. So think about the date dimension. We have year inside of the date dimension. Year is a number, but we never use it as a number. The only way we use it as a number is that we sort by it. But year is, although it is a number, it's a label we put on everything in order to analyze it. Each of our dimensions groups together labels that are related to one another. So think about product. A product has a color and a class and a style and a model number and a long description and a short description and a default label. It's got all these things that describe it that are all labels for that product. They're sort of almost synonyms. All of those things that belong together are what make up that dimension. And what we do is we put a key on that dimension, connect the key to our fact table, and then anytime we need to look up any of those values, we don't have to have that text field copied into every single fact row. We can get it from our dimension table. One of the things you'll notice in dimension tables that's sort of a way to tell it's a dimension table is it'll have a lot of fields that are text, and generally it's not a very large table. So in a normal star schema, you might see hundreds of rows, tens of rows, maybe even hundreds or thousands or millions of rows, but it'll be much smaller than your fact table. When you start to see one row per fact table, you want to question and think, am I really doing this right? You might be doing it wrong if you have as many rows in your dimension as you do in your fact table. I've seen it done, but it's not the recommended way to do things. Another hallmark that you're going to want to pay attention to is, can this information change over time? Is this something that changes? A person can change their name. A product can change the way we describe it. A department might change the department head. If it's something that changes over time, it probably is a dimension. So you want to think about those things when you're building your model, and when you're looking to say, am I building a dimension or a fact? Ask yourself, is this something that changes over time? Is it mostly text? Are the numbers that are in that labels not really numbers? If it is, then you're probably talking about a dimension. Now let's talk about what a fact is. I always explain this to my students as it's a business event. It's something your business does. It's something that occurred. The fact that it occurred can never change. Doesn't mean your computers get it right, and you don't have to change the fact because your computer screwed it up, but the fact that it happened is what you're looking for. So I made a sale. I attended a class. I bought something. I had a procedure done. I was charged for something that I did. All of those things are events that occurred, and they're events that the business tracks, and what makes them unique is those are the things that have all the numbers that we analyze the business by. So when that event happened, there's a bunch of things that we measure at that moment. How many items did I sell? What was the total cost? Did I pay tax? Was there a shipping charge? How many days did it, after it was supposed to be delivered, did it get delivered? How many of these things did I buy? Anytime you're looking at data and you're seeing these kind of numbers associated with things, and it's something that it occurred, it doesn't change the fact that if you want to change the fact that it occurred, you issue another transaction to roll it back. Those are your fact tables, and that's what you want to look for. You want to look for these. A verb is my biggest tip. We sell, we buy, we do something. It's got some numbers associated with it, and it doesn't change over time. The other thing that makes a fact table, you can really recognize it, is it generally is the largest table in your database. Normally your facts are where the majority of the rows are. They tend to be lots of large tables in terms of number of rows, but they also don't have a lot of columns associated with them. So if you think about a sales order line item, it really has the unit number, the number of units sold, and the price. And we can calculate everything off of that. We can calculate the tax, we can calculate the grand total, we can calculate the shipping charge. Maybe it has it in there, but at minimum it has the number of items sold and the price of the item as it was sold. All right, so a fact table, when you're looking at data, you're looking for that table that has lots and lots and lots of rows and is something that probably shouldn't be changing over time. I say that knowing that I have yet to get a system this year where they actually are building a warehouse where the facts don't change over time. As much as we like to think that they don't, the reality is a lot of your businesses are going to go back and update their facts. It's a challenge for you to deal with if that happens, but you want to think of it more from a logical perspective. Did it change in the past? The fact that it occurred and the fact that I just used the word fact in that statement tells you that you're looking at a fact table and not a dimension table. One of the ways that I like to think of a fact table is this is the association between those labels and those numbers. So remember a minute ago I was pointing at the airline and the airport table, and I said we needed a table in the middle that let us associate our airlines to our airports. That fact table is that association between all those labels, and it gives me those numbers that describe that association. So we landed this many times on time and this many times late. So let's start getting into the meat of this, which is PowerPivot and the data model. So I said a while ago, PowerPivot uses a logical model to analyze data. When you build your data model, what you're doing is building a logical model. You're telling PowerPivot about the rules and the description of your data. PowerPivot is going to store the data a completely different way. We don't have to care about that. What we have to care about is making sure that we describe our data in a way that PowerPivot can then build the cube that it needs to build and process the data to come up with the correct numbers. I think I have this in my presentation a couple of times. If you do your design wrong, not only do you get poor performance, but you get bad numbers. I've worked with customers who have built cubes and done it wrong and delivered to their managers bad information because of a mistake in their cube, and it's very painful. When you build your data model, you have to build it with the right structure so that you get the right numbers. How you design your data model in PowerPivot drives how your storage engine processes the data. So your job when you build the model is you're going to build this logical model, and you're going to tell PowerPivot, here are all the tables that I'm using, and here is how I connect those tables together. That's really all you have to tell PowerPivot for it to do the correct analysis. If you describe your relationships correctly and you have the correct values inside of the rows and the tables, then you're going to be able to build analysis that is meaningful. One of the problems that a lot of people who build PowerPivot have is actually testing. The numbers, because you deal with aggregates, the numbers can be very large, and you may not realize right off the bat, oh gee, I made a mistake doing that. Sometimes you're lucky and like the numbers will be so ridiculously off that it's easy to spot. But you have to really pay attention to this, because if you happen to connect your data incorrectly and you meant to connect one row to one row, but you actually connected one row to many rows, you can get the wrong numbers in your analysis. So the data model in PowerPivot, it's very critical to understand when you build this logical model, you are telling PowerPivot, here's how I put the data together, and when you're doing your aggregations PowerPivot, here's how this row matches to this row. Either once, one-to-one, one-to-many. All right, when I teach PowerPivot, I teach this standard workflow, and it's extraction model presentation. What I decided is that that's not really even the best workflow. It really should look more like this. It really should look like preparation, which is a huge effort, and then extraction modeling presentation. I got to go through some of these slides a little bit quick. So let's talk about that preparation phase. Let's talk about what I tell all my customers. I tell them, build your data model on paper. Understand what your message is. What am I trying to analyze? That's going to be in your fact information. How am I going to analyze everything? That's going to be in your numbers. We measure sales by. We look at reservations by. Those are all the things that are going to be how you analyze your numbers. If you've done that correctly, what I tell my customers is draw an empty star schema. Draw something that looks exactly like these blue boxes that I have on the table or on the screen. Put it on a piece of paper. You'll notice that what I have there is a fact table that has keys and numbers, and that's all it has in it. And I have dimensions surrounding it. I have 5. Our recommendation is 3 to 8. Try not to have more than 8, or 5 to 8, I guess I have. Try not to have more than 8. If you do, it starts getting a little unwieldy for the people that use Excel. But build something that looks like this, and then start filling it in with the data that you think you're going to use. So put all of your measures. So I'm looking at my invoice, and when I look at an invoice, I see customers on the invoice. And customer is something that I analyze sales by, so I'm probably going to have a customer dimension. Next, I'm going to look at the products that are on my invoice. Since I analyze sales by product, that's probably a dimension too. On my invoice, I have shipping information, maybe a shipping company. That might be one of my dimensions. Probably the most commonly used dimension across everything is date. If you build a star schema and you do not have date, you should be questioning whether that's a good star schema. I'm not saying it isn't, because people always do the exception, but I would say 98% of the pivot tables I've ever seen, date is one of the things that we analyze by. How does data change over time? As I'm going through here, I'm going to put any fields related to the customer in the customer dimension, any fields related to product in the product dimension. The only thing I'm going to leave in the fact table are the keys to those dimensions and the measures that go with that. So in my case where I'm talking about sales as my fact, I'm going to put those numbers associated with the sale, number of items sold, number, the total cost, the profit, blah, blah, blah. I'm going to put all those numbers in my fact table, and I'm going to build this model out with all the data that I think I might be importing. I will tell you that for the 12 to God knows how many times I've taught this class, I have to hammer this into people. Don't start importing data before you do this. If you are building your pivot table model and the first thing you do is start importing data and you haven't thought this through, you're going to bring in data you don't need. You're going to bring in data that doesn't make sense. You're not going to be able to connect your data together. I strongly recommend build your model on paper. If you do this, the rest of PowerPivot is going to be so much easier. And here's why. If you build that star schema, then what happens is all of those dimension tables that we just built are going to end up in the filters, columns, rows, and slicers. That's exactly what filters, columns, rows, and slicers are. Those are labels that we use to analyze our numbers. All of those numbers, which we call measures in the fact table, are going to end up in the values section. If you've built a good star schema in PowerPivot, PowerPivot becomes your cube that you build in the background is easier to process, it's better performing, and it's easier for your customers to understand. If your customer sees some of your dimension data sitting in a fact table, which can happen, it confuses them. Well, how do I know if I get it here or I get it here? So I strongly recommend if you take the time to do this organization ahead of time, PowerPivot's going to work a lot better for you. So define your facts. Look for your transactions. I'll tell you real quick, there's a couple of different types of facts that you want to pay attention to. As much as possible, you want to look for what we call accumulating transactions. That's where I have one transaction that does the sale, one transaction that adjusts the sale, another transaction that reverses it, another that adds to it, as opposed to what we call a snapshot transaction. Snapshots are things like nightly balances. So if you're pulling from a data warehouse and the only thing in your warehouse is a nightly balance, you're going to have a little bit more trouble analyzing that across time. You can probably analyze it by warehouse, by product, by customer, but you're going to have a little more trouble analyzing it by time because you don't know what actually happened during the daytime. If you think about it, if you have 3 in and 3 out every day, you're not going to see all of those sales transactions. You're just going to see the end result of what it was at the end of every night. I'm not saying you can't do analysis. PowerPivot has wonderful features that will help you with balance type analysis, but you should know that that's what you're doing. Make sure that when you're defining your fact table, you understand whether your fact is accumulating or a snapshot. Think about your measures. Don't wait till you get all the data in. Think about the measures right up front. Because one of the things you have to know is, am I going to have to calculate that value at every row, or is that value an aggregate? Understand your measure when you're building your star schema so that you know, do I need it at the row level, or is it going to be an aggregate value that I can create as a measure? Make sure you understand the source. Where do I get that data? And I cannot stress this enough. At the beginning of your career in PowerPivot, keep it simple. One fact table. One fact table, 5 to 8 dimensions. If you try to get more complicated than that, you run the risk of just creating something that's almost unsupportable. Define your dimensions. Look for those nouns. Think of those person, place, or thing that we analyze our business by. And the most important thing, make sure you understand how those dimensions are connected to the facts. I can't tell you how many people I've seen go out and bring in fact data, and then they bring in a dimension table, and then they realize there's no field in the dimension that's going to connect them to the fact. The whole time you're doing your planning for your model, you have to think about those keys. How do I match the keys up? How do I match this row in this table to this row in this table? And you want to make sure that when you're doing your design, you understand how that works. And then look for those relationships. So go look for that sentence that says, each one of my A has one or more B, or each one of my A has one and only one B. If you can find that one-to-one relationship, that's what you can use in PowerPivot. And that's what's going to take your star schema. That one is going to be your dimension. So know the keys. I said in here one-to-many relationships don't matter. If you find the one-to-one, the opposite of it is generally the one-to-many. So your job is find the one-to-one and not worry about the one-to-many, because that will come automatically in the relationships. The last thing I'll tell you is put all the fields on the model. Go through and look at every field you're going to input and find a place for it on the model. If you can't find a place for it on the model, it probably doesn't belong in the model. So think about a field. I'm bringing in my sales table, and there's a field called description or comments. That's my number one pet peeve, is people who bring comments into a PowerPivot model. What are you going to do with comments? If you put it in the fact table, you can't do anything other than count how many comments were made. Is that really of value to you? You want to make sure that everything you bring into your model has a home inside of this star schema. And if it doesn't, question whether you really need that. Remember that your hierarchies are normally going to be in your dimensions, but the big tip I can give you is watch out for these denormalized fact tables. We have a lot of warehouses out there that denormalize their facts, their dimensions into the fact tables, which helps a lot with reporting, but it's a challenge in PowerPivot. So I'm going to go through very quickly. This deck, I'll make it available after in case I don't happen to get all the way through this. If you did it right, then when you go to that next step of importing data and the step after that of actually modeling the data in PowerPivot, your data sources will be well defined, your import process will be meaningful, and your PowerPivot model will be much easier and more meaningful for you to use. The most important thing, however, is your data analysis will be correct. If you follow this step in planning and preparing, then when you actually have to go into PowerPivot and build a fact table and build a dimension table, you're going to end up with a result that is better than if you just randomly start pulling data. This is why I tell people to plan the model first, spend the time up front to plan it. I will tell you Power Query is your best friend. Power Query is an awesome tool. If you haven't seen it, you should go out and look at it. Not everybody likes to use it because it's still a pretty new tool and there's still some growing pains with it. But the number of transformations that you can do in Power Query to help you build that star schema in a nice, effective format are awesome. I strongly recommend that you use Power Query as opposed to just importing in PowerPivot because of the amount of transformations you can do. Now, the alternative, if you don't want to use Power Query, is be friends with your DBA so that they can help you write good queries. and they can help you extract data in a meaningful format. If you've planned your data model on paper, you can take that to a DBA and say, this is my end goal, help me build this model. I am going to have this section about data sources up available to you guys later, but I think we're running out of time, and I want to just scroll through to the end. So I'm telling you in these section of slides what I think your best sources of data are. You can go look at this. I'm going to remind everybody, don't try to answer all questions for all people in one model. When you're planning this, I hear on a regular basis, I hear, oh, somebody might need that later. That's not a good reason to pull data into your PowerPivot model, especially not your beginning ones. Try to only pull the data that you need to answer the questions that you think are related to that model. Don't try to answer all questions. I'm also going to say use the right tool for the right job. I can't tell you how many times I've taught this class and people get frustrated with PowerPivot because they can't make it do something. But what they're trying to make it do is be an ad hoc query tool. And if you use, you know, a hammer to screw in a screw, it doesn't always work so well. So my advice is remember that it's an analytics tool. It's meant to aggregate and analyze data. It's not really meant as a reporting tool, but it does build great reports and dashboards and things like that. So just kind of keep that in mind. Here's some other recommendations. Be friends with your DBA. I do have an exercise that if you take a look at this at the end, I've given you some information here, and I've kind of given you an example of how we would go through this process and how I would look at it to build out a star schema. So if this was my case, I sell widgets, I have salespeople. This is probably not the most politically correct solution analysis, but I want to know if our longtime sales guys are doing as well as the new guys. Excuse me. And I want to know, are our longtime sales guys the older guys or are they the younger guys? So I'm going to build this report out. I need to build this star schema in order to do this analysis. And this is an example of a star schema where you have to go to multiple systems. And this is the mental exercise that I go through when someone asks me to build one of these power pivots. So I go through and I get all those requirements, and then I go down to the bottom and I say, what is my fact, what are my dimensions, and what kind of measures do I need? So I would look at this and say, okay, my fact must be sales. I have salespeople as a dimension. I have warehouses as a dimension. It looks like my measures, I get commissions. I have sales numbers. Excuse me. And then I also have some attributes that I can identify in this. I have age as one of the attributes of my people. And I have employees and I have salespeople. So I'm going to go through, and as I build my PowerPivot model, I'm going to be asking myself, what are my facts? What are my dimensions? And what kind of measures do I need? I'm going to leave this up there. I will post this on my blog post later, and I'll give you my answers to all of these questions if you want to go through that exercise yourself. So hopefully this has helped. If you have any questions, like I said, I'm going to follow up with a blog post on this. And again, my goal here was to give you some terminology, some methodology, sorry about that, and some of the planning that you do that's ahead of PowerPivot before you actually get in and start building a PowerPivot model. I think for as many times as I've taught this class, this is the area that people struggle with the most. And hopefully I've given you some information here that will help you as you go to build those PowerPivot models. It'll help you understand what's going to work best with PowerPivot. Tammy, are you out there?
I am. Can you hear me?
All right, I think, yep, I think we're at the, like 2 minutes over, right?
About 3, but that's okay.
Okay, well, close enough.
It doesn't appear that there's any questions. The only question that we did have was, would you be sharing the slides with the attendees? And you already made the comment earlier that you would be. So you can work on that blog and send it over to us, and we'll put it out there.
And you'll email it out, right?
Absolutely.
Good. If anybody has any questions, feel free to keep submitting them, I guess, for a few minutes, right?
Correct.
Okay, and feel free to give me an email if you have a question. Like I said, I think this is all planning information. It's all what you do ahead of time. So let me know if you have any questions about it.
Kathy, they would like to know where you would be posting your blog.
So my blog is at Ms. Kathy V, KATHYV.com. I probably should have put that on the front slide, huh? I forgot about that. I haven't blogged in a while, so this will be a first blog post in a while, but I will work on that this afternoon and try to have it out this evening. And then, again, feel free to ask me questions if anything comes up.
They ask if you could repeat that one more time.
MSKATHYV as in Victor, MsKathyV.com. It's a WordPress blog, so you just need the .com on it.